Android, the operating system powering billions of smartphones, tablets, TVs, and even cars. But have you ever wondered how it's actually made? Today, we're diving into the real-world journey, from raw source code to the Android OS running in your hand. Our story begins in the early 2000s with a small startup called Android Incorporated, founded with a vision to deliver a smarter mobile experience. The team's innovative ideas caught the attention of Google. In 2005, Google acquired Android Incorporated, setting it on the path to become a fully open-source project dedicated to flexibility and innovation. This collaborative spirit laid the groundwork for an OS designed to work on a vast array of devices. At the heart of Android lies the Linux kernel. This critical layer manages hardware resources such as memory, power, and device drivers. Android engineers customize the standard Linux kernel to optimize for mobile devices, enhancing power management, implementing multitasking, and integrating drivers specific to mobile hardware. By adapting the Linux kernel, Android ensures a reliable base where the rest of the system can thrive. Once the kernel is in place, Android's architecture builds upward by adding native libraries and a runtime environment. Here's how it works. 1. Native libraries. Android incorporates a rich set of C and C++ libraries. Examples include WebKit for web content, OpenGLES for 2D and 3D graphics rendering, and SQLite for data storage. These libraries provide essential functionalities that enable smooth, responsive features in the OS. 2. Android runtime. ART. Initially, Android used the Dalvik virtual machine. Today, ART takes center stage, employing ahead-of-time AOD compilation to convert application bytecode into optimized machine code. This results in improved performance and battery efficiency while ensuring robust app execution. Above these core layers is the Android Application Framework, a comprehensive toolkit that simplifies building mobile applications. This framework offers critical high-level services such as Activity Manager, controls the lifecycle of applications and manages multitasking. Window Manager, handles how content is arranged on the device's screen. Content Providers and Resource Managers ensure efficient data sharing and system resource management. This modular architecture not only simplifies app development, but also guarantees that apps function consistently across different devices, regardless of the underlying hardware variations. The creation of Android OS is an immense collaborative effort, coordinated through the Android Open Source Project, AOSP. Here's how the process unfolds. 1. Version control and code contributions. Thousands of developers worldwide contribute code that is managed through Git and reviewed on platforms like Garrett. Rigorous code reviews ensure adherence to stringent quality and design standards. 2. Automated build systems and testing. Initially driven by Makefiles and evolving now with systems like Gradle, the build environment compiles millions of lines of code into a coherent system image. Continuous integration systems run automated unit tests, integration tests, and extensive performance profiling to catch and resolve issues early on. A defining strength of Android is its adaptability. This flexibility is achieved through the hardware abstraction layer, HAL. The HAL serves as a standardized interface between the system's core and the device-specific hardware. In doing so, it allows manufacturers, OEMs, to integrate components such as cameras, sensors, and touchscreens consistently, even when the underlying hardware varies widely from one device to another. This careful separation ensures that the Android OS maintains a uniform performance and user experience across a global ecosystem. To power billions of devices, Android must be reliable and secure. This is achieved through an exhaustive testing and debugging process. Unit and integration testing. Automated tests check individual components as well as their interaction within the system. Emulators and real device testing. virtual devices, and physical hardware provide environments to simulate real-world conditions, catching issues like memory leaks and performance bottlenecks. Debugging tools. Utilities such as the Android Debug Bridge, ADB, and performance profilers help engineers diagnose and resolve any issues. These iterative cycles of testing and refinement ensure that each release of Android OS not only meets high-quality standards, but is also continuously improved based on real-world feedback. Once the code is integrated and rigorously tested, the final phase is packaging and release. The stable OS image is made available to device manufacturers, who then customize it further based on their hardware capabilities. In parallel, the AOSP community continues to release regular security patches and updates, ensuring that Android OS remains resilient in the face of emerging challenges. This ongoing evolution is a testament to the platform's adaptive design, the power of open-source collaboration, and a commitment to excellence. From a modified Linux kernel to a layered architecture that supports thousands of devices worldwide, the creation of Android OS is an intricate, highly collaborative endeavor. It is a journey fueled by innovation, rigorous testing, and continuous refinement, an effort that has transformed mobile technology and continues to shape our digital future. Thank you for joining us on this detailed exploration of how Android is made. Stay tuned for more behind-the-scenes looks into the tech that powers our world. If you found this exploration fascinating, please take a moment to like this video, share your thoughts in the comments, and subscribe for more in-depth tech adventures.